Ladies and gentlemen, boys and girls, welcome to the greatest event happening in my life this week. And man, so this week I've been doing Eloquent JavaScript. I've read through chapter 1, chapter 2, chapter 3, and chapter 4. And today I thought I might do a review of the story so far, and then we're gonna get to jump into chapter 5 and then maybe record that one as well. But there's been so much fun, and I really hope to keep doing this, just even as a personal process, a personal way for me to interact with code, a personal way for me to learn, to push myself to do the actual learning that I'm supposed to do. And so it's exciting. Let's go, man. Yeah, so this is Eloquent JavaScript, the book, the online book that I've been doing, and I've been doing this online. It's been so much fun, man. So much fun. I've been really, really enjoying this experience. So, this is chapter 5, high order functions, and I really, really wanna like read through this thing. But no, let's do the story so far, okay? So what do I have here on my browser? Let me talk about what I have on my browser. And this is my setup. I got coffee too. Really hot coffee. Yeah, that's my companion for this process. I have in here my GitHub, which this is my GitHub that I created 17 days ago. And I thought I'm gonna use this GitHub to just learn a bunch of things, and especially learn Eloquent JavaScript. It's set to private. But how I'm envisioning in this GitHub, how it's going to be, I had thought in here I'm gonna have the course, and when I open this file, I'm supposed to have, you know, um, have a bunch of course in here. But then it was so crazy because when I came here, I didn't exactly know like what I'm supposed to do. So that was crazy. I was like, okay, so what am I supposed to do? Am I doing it right? Am I doing it wrong? So I figured I'll come back when I really know how to do it. I'll just got started on GitHub. But what I did, I can show you what I have in here. I have this read.md. It's a markdown file, and I'm also learning about markdown. And then I have this eloquent javascript.txt. And you shall see here, this is where I shall put some of my notes from the book Eloquent JavaScript. And I was supposed to put some notes in here, but I think I did not do that. What I must have did, gist with a G or a what? Gist. Let's try gist with a G. GitHub has another platform called Gist. Create a new gist. Okay, let's go to loop1.js. Alright, so this is my gist on GitHub. And I found out that in GitHub, in gists, you can have code snippets. And this is what I intend to do. So for example, this is loop 1 when I was learning about loops. In this loop, write a loop that will iterate from 0 to 20. For each iteration, it will check if the current number is even or odd and report that to the screen, e.g. 2 is even. So let I be 20. And then for let I is 0, we start our iteration. I is less than or greater or equal to 20. This is our Boolean, and then we're going to add. And I remember being very confused, especially after this process. Like, yo, how can you read this syntax? And I must have watched a couple of YouTube videos, which is something we can do today because I'm trying to do the story so far. And then you run these parameters in here. This is an if if I has a remainder, remainder 2 is equals to 0, console.log I plus this string is even, or else console.log I plus is odd. And because it's 20, it would have told you it's even. And if you run any other number, for example, let's copy this code, Control C. Today I'm using the Windows machine, and let's clear here. Then let's Control V. Let's step out of it, and CodePen will run our console. It's not as fast as just doing it on our browser. It has printed 0 is even, 1 is odd, all the way to 20 is even. And this is a really good lesson in loops. All right, so that's cool. Maybe I could save also this code snippets to my should I really though? I don't know. Let it just stay here for a while. As long as I have it on my gist. And then I had this other one that I was supposed to work on, but I didn't actually. Oh yeah, so here it was understanding the traditional for loop. So for let I be 0 when I, and what is this one doing over here? It's less than r.length I plus plus, you close, and then maybe, can I edit this now? I can't. So in this loop, first we keep the number of iterations we have made, which usually would start as 0. So for the iterations is 0. Hence, let I be 0. Then we need a condition to stop the loop. Hence, I is less than the average length. That is our Boolean. If true, it will stop at the length. Then we counter each time an iteration is completed. So here is a counter. We counter each time an iteration is completely. It's kind of like saying start here, stop here with the Boolean, and then do after each here. So start here, then you'll stop here, but you'll do this after each completed loop. And I remember just being very fascinated after it took me a while to understand this. And I've been on chapter 3, chapter 1, chapter 3, I think. Yeah, I think chapter 3 is when we are introduced to the for loop. And it's been really fun going through this book actually. Let's see. Yeah, it is. It's in here. This is recursion. I remember just wondering to myself, bruh, what is that? It has to be in, maybe not in functions. It has to be, yeah, in program structure. Somewhere here is when you're going to find our loop. Okay. And it was funny because I had such a hard time of getting such simple basic ideas. And so this is the story so far. And what I had wanted to do is I also keep a page here in Notion called JavaScript ES6, and I'd wanted to update what I'm also learning and if I am understanding it. And this was to be my JavaScript challenges and coding, but here is some of my notes that I had wanted to keep in here. So I thought today, because I'm doing Eloquent JavaScript ebook, I'm going to open this book and I will jump in and try to do a short summary from the book. So we're going today, we're just going to take our time, really remind ourselves what we've been doing throughout the week. And if I'm not wrong, I uploaded the PDF over here, which is something good that you can do in Notion. That we can just work from here. I wouldn't need to go in and jump into this other page. However, it's cool. So lesson 1 is values, types, and operators. So let me just create and here we're getting into Eloquent JavaScript curriculum. Okay, curriculum, and we're just going to take our time and really reflect on what we have learned throughout this week. So let's go. So lesson 1, which could be like let's make this like a H2, and we're going to say lesson 1, and it's going to be values, types, and operators. All right, that is so cool. So you see, number 1 is value, so we're going to go with H3, and we're just going to say values. All right, so let's remind ourselves what was a value. So what was a JS value? I think a value is anything that we give it a binding on the machine, on our memory. And what you start learning very quickly, I think the lesson here in values was that that things need to be held in a machine for them to exist. Let me try and explain this. That if you declare anything in a machine, in your computer, without asking the computer to hold it, it will just disappear. So a value, I think it's something that has been held. And you know what? Let's just go and find out whether I actually got it. Values. Yeah. So it's right. So it was bits. And there's only data. So you need to hold this bits. So how can you elaborate what a value is? To be able to work with such quantities of bits without getting lost, we must separate them into chunks that represent pieces of information. In a JavaScript environment, those chunks are called values. Right, so these are bits that have been made into chunks so that JavaScript can hold it. Though all values are made of bits, they play different roles, and every value has a type that determines its role. Some are functions and so on. So to create a value, you must merely invoke its name. This is convenient. You don't have to gather building materials for your values, pay for them. You just call one and whoosh, you have it. They are not really created from thin air. Of course, every value has to be stored somewhere, and if you use a gigantic amount at the same time, you might run out of memory. So I think a value is bits stored in memory that JavaScript can call, or something like that. Okay, yeah, so these are bits that are stored into memory that JavaScript can call. All right, and maybe I'm just gonna write that. So these are bits stored into memory that can be called by JavaScript. Right, so this is a value, and a value can be so many things. And then the next thing we'll talk about is numbers, strings, unary operators, and then Boolean values. So I think these are the types of values, and these are value types. And I think that's what I can write. H3, these are value types. And in value types, we have numbers, strings, Boolean, numbers, strings, Boolean. What other? They're supposed to be like 5. Are they? How many? How many? How many? Or 3? How many value types in JavaScript? Is it 3? Are they just 3? They're 5. Yeah, you know they're 5. This is 3. Numbers, strings, and Boolean, but this is 8. Why is it 8? All right, I know why it's 8, because null data types and identified number data types, big init data types, and where's another Google one with the 7 data strings, number, Boolean, null, and unidentified. And I think it's important that I added. You can see that I remembered string, number, and Boolean because these are primary. But then in under number, we also have null and unidentified, and then so under also number we have types of numbers. So let's go. So and then the next thing in numbers, we're going to look at the arithmetic, and then in arithmetic, we're going to talk about operators. And maybe we can go here. And then, so here, how can we say it? We can talk about arithmetic. And under arithmetic, we have operators, which is an important thing in JavaScript. And so what I did, especially just in chapter 2 or chapter 1, was just really like learning the syntax. And so these operators are like add, which is the plus sign, and then my minus, which is the minus sign, and then greater than, which let me first of all write it, greater than, which is the less than, which is the left something bracket, greater than or equal to, which is written as such. And then less than or equal to, which is written with the all right. And then we also have Unary Operator. We have also Unary Operators. Which other operator do we have? What am I forgetting? We have a bunch of operators. Let's remember. Special. So in numbers, we learned that JavaScript can do all types of numbers. Okay, the value, the number type, is just like 13. This is how 13 is represented. And JavaScript uses a fixed number of bits, 64 of them. And so JavaScript can also represent fractional numbers, and it can also represent an exponent. Right? So that was something important that you need to learn with numbers. And I think why it's important is because maybe there are some languages out there that you have to define the type of number. If it's a whole number, you have to define whole number. If it's a decimal, a fractional number, you have to define as a fractional number. But JavaScript just takes all of them as you just represent, it calls them numbers, no special name for that. Special numbers, we also have infinity and minus infinity, which represent the positive and negative infinities. And so here we were told just to not really think so much about this, because it will give us not a number. All right. Then strings. So the next basic data type is a string, which is to represent text that are written by enclosing the contents in quotes. And maybe we can jump here and say they are written by enclose the contents in quotes, e.g. this is my code, exclamation mark, then close it. So that's a string. All right, and then that was that. There wasn't really so much. This was a backslash to show that when you write it in a string and you have a backslash, it will enter. It will create a new line. And then similarly, a T after a backslash means the tab character, which takes the following string. This is the first line, and this is the second, and it will enter. All right, really nothing. And then we also learned about concatenation, which is an important method to learn in JavaScript, that when you add strings together, it will paste them together. It's called concatenate. All right. So unary operators. So here we learned about operators, and then I guess you can say and operators that we have we can also say that we have symbol operators and unary operators. I think it's important to know. So these are unary operators, these are symbol operators, and then now we have unary operators. And then so here's where you can have something like type of, which is an operator that operates like so. An operator, what an operator does, it adds two values and gives a different value. And let's see if they've defined that somewhere. That was a good explanation to start understanding what our value are. All right, values. No, not operators. And then it's supposed to say that here, like in JavaScript, putting operator between two values will apply it to those values and produce a new value. So an operator is a symbol, or how can you say it? How can you say it's something? Because if you say symbol, then we are leaving unary operators. What can we say? Anyway, okay, so we can say, then let's combine symbol and text. So an operator is a symbol or text when you put between two values, and it will apply it to those values and it will produce a new value. So for example, if you put a plus, it will apply and produce a new value. Okay, unary. So this is a type of, this is written as a word. It's a type of operator, and when you say console.log type of 4.5, it will tell you this is a number. When you say console.log type of x, what is this type? it will give you a string. So we use the console.log in example code to indicate what we want to see, the results of the evaluating something. More about that in the next chapter. So the other operators shown all operated on the values but type of, which takes only one. Operators that use two values are called binary operators. Okay, fine. So now here we also have binary operators. Right, let's then, so what's a binary operator? So it takes operators that use two values are called binary operator, while those that take one are called unary operators. The minus operator can be both used as a binary operator and a unary operator. And then so you went to Boolean, which is another value type of JavaScript here. And so Boolean is true or false. Basically, this is true or false. And it's a logic that gets applied to a statement. So Boolean is true or false. And we're going to see how that is used. And very fantastically, when you just understand this basic syntax, you start understanding JavaScript. So are we in Boolean? Alright, so it's often useful to have a value that distinguishes between only two possibilities like yes and no, or on and off. For this purpose, JavaScript has Boolean value type, which has just two values, true and false, and written as those words. Here is one way to produce a Boolean value. Console.log 3 is greater than 2. The engine will tell you, oh, this is true. And then 3 is less than 2. No, this is false. The greater than and less than signs are traditional symbols for alright, fine, that's just what I said. Applying them results in a Boolean value that indicates whether they are true, they hold true in this case. Okay, alright. Alright, not important. When comparing strings, JavaScript goes over the characters from left to right, comparing the Unicode one by one. Other similar operators are greater than or equal to, or less than or equal to. Oh yeah, these are others, equal to and not equal to. This I need to add these operators here. So those are the logical or and the logical and. So there was equal to and what is the neighbor doing? Okay, I need to space not equal to, and then there was the logical and then there was the logical or. So this could be and this can be or, and I wonder if that's an operator, but we're going to find out as we're doing our review of what we've learned so far. Pretty basic things. This one I understood. I didn't have a problem understanding the basic syntax. When you start building on top of JavaScript is when now my mind starts just taking a beating. So logical operators. Alright, so these are called logical operators. So there are also some operations that can be applied to Boolean values themselves. JavaScript supports 3 logical operations. So it's and, or, and not. And maybe I need to remove this or maybe not like that. Maybe I need to. So these are unary operators. We've seen, but I mean, come on, man. You see, the problem with Notion is sometimes it can select an entire block. Unary operator, binary operator. And then I think also now logical operator, which is up there. So there are also some operations that can be applied to Boolean values themselves, and or not. This is the AND operator, represent logical AND. It is a binary operator, and its result is true only if both the values given to it are true. So console.log true and false, true and false is true. Console.log true and true is true. This is the logical OR. It produces true either if the value given is true. So console.log false or true, true. Console.log false or false, it's false. There's no way it can be true. Not is written as an exclamation mark. This and yeah. So yeah, this is. I guess this is not. I need to denote that. Let's. There's the not, just not, and then also of course there's the not equal to. Yeah, I will discuss. And so this is here is just when you understand those things, it now starts making sense how you can build. You can now come and start building logic and apply it to like the JavaScript engine. So the last logical operator I will discuss is not unary, not binary, but ternary, operating on 3 values. So unary only operated 1. Binary could operate on 2, like the -1 or the logical ones. And then the ternary operates on 3. It is written with a question mark and a colon. You see, this is something I had forgotten. Right? So ternary operator, and then so we have ternary operator. Also we have logical operator. So you can take these operators after now you've learned the operators and break them down. You can have operators, unary, binary operators, logical operators, and ternary operators. All right. And so let me just jump here and put in the ternary operator, which I'm gonna put them in, like in quotes, and I think it's this or this, the other way around. Let's find out. Yes, oh, it's the other way around. So it has to be a question because this has to refer to the left side. So let's or the right one, it has to refer to 1. Is 1 true? How can you read this? How do you read this code, guys? False. All right. True, 1 and 2. 1 is true. Console log false, 1 and 2. False is 2. I have no idea. All right. I have no idea what that is. Also have empty values, man. So they have null and unidentified. And they used to denote the absence of a meaningful value. So yeah, it's very important to also capture that. Maybe let's have it as 4. Okay. Let's say, how can we say it? How has he put it? Empty values. So let's just add it here as empty values. Here we have null and unidentified. undefined. So I never used to think it's important to learn this, but as I was doing some research the last few days about unidentified actually is written into the JavaScript engine. It just means that yes, we know, like, you've written a piece of code over here, we just don't know what it means. For example, if I go and find my developer tools, Control Shift I should have just done that. I wonder if I can have a bigger console instead. And so let's go to the console. If I said let my learning curve be fast, right? So it said undefined, right? And I think this is what I've written undefined. What have I just done in my notes? Yo, this is wrong, bro. It's undefined. Ooh, I would have written some wrong notes for myself. So that means, as you can see here, not here, you can see here that let my learning curve be fast. The JavaScript console says, okay, fine, you have something called fast, but it's unidentified. But you've created this binding. But it's unidentified. So this means it actually exists, and it's good to know undefined. It means it has no meaningful value. It's just a string. So, and then and then yeah, it's whatever. You get. So many operations in the language that don't produce meaningful value, you'll see some later, yield undefined. Simply because they have to yield some value, like the way mine on the console log has yielded undefined. Alright, automatic type conversion. I think this is another powerful thing to understand when you're just getting into JavaScript, because JavaScript is a very liberal language, right? And maybe we can write that, because these are notes that people have said over and over, that JavaScript is a very liberal language. It will accept almost anything you throw at it, said someone on YouTube. So in the introduction, I mentioned that JavaScript goes out of its way to accept almost any program you give it. It even programs that do the odd things. This is nicely demonstrated by the following expression. So console.log 8 times null. We know this should give us null, but it gives us 0. Alright, JavaScript looks at null, it says, so there's no number here. I don't know what you're trying to do, you stupid man. You don't know math. So I'll just tell you 0. And when you say console.log, this is a string called 5 minus 1. JavaScript says, hey man, this is a string. Or maybe this is what you meant. Alright, let me give you 4. But sometimes when you use the word plus, because this is also another symbol for concatenating, it will say, all right, so 5 as a string plus 1. Oh, maybe 1 is a string, you just forgot. So let me concatenate that for you. And when you say console.log 5, which is a string word, times 2. To tell you, man, you must be crazy. This is not a number. And when you say console.log false is equal to 0. Like, okay, fine. You're right. That's true. Okay, so I think what you learn from listening to these people is that other languages are not like this. Other languages are very strict, and it will not give you the same result. It will give you an undefined, fail, you're stupid, try again, don't try again, close the computer, go take a walk, type answers. But JavaScript will try and figure it out for you. I wonder if he said that in this line, so let's just look at it. When an operator is applied to the wrong type of value in JavaScript, it will quietly convert that value to the type it needs, using a set of rules that often aren't what you want or expect. So this is called type coercion. All right. The null. And then maybe we can add. We throw at it. This is called type coercion. Coercion. Bro, I don't even know how to type. Don't even know how to spell coercion, bro. It's with a C. Huh. Who's stupid now? The null in the first expression becomes 0, and the 5 in the second expression becomes 5. String to number. Alright. Sorry about that. Yet the third expression plus tries string concatenation before numeric addition. So 1 is conversion, and just exactly what I've told you. All right. When comparing values of the same type using double equals, the outcome is easy to predict. You should get true when both values are the same, except when the values of not a number. But when the types differ, JavaScript uses a complicated and confusing set of rules to determine what to do. In most cases, it just tries to convert one of the value, that, and we know that too. Right, now, this is where I think just this last part of this topic was something that was very important that I thought I need to really understand, because what you're going to see that immediately the author is going to stop using logic the way I'm speaking logic and start putting it into code. Alright, but what if you want to test something refers the precise value false? Expressions like 0 equals false and string equals false are also true because of the automatic type conversion. When you do not want any type of conversions to happen, there are two additional operators, which is the triple equals and the not double equals. The first test whether the value is precisely equal to the other, and the second test whether it is not precisely equal to. So string equals false is false as expected. So short-circuiting of logical operators. The logical operators and or handle values of different types in a peculiar way. Alright. They will convert the value on their left side to a Boolean type in order to decide what to do, but depending on the operator and the result of that conversion, they will return their original left-hand value or the right-hand value. So the OR operator, for example, will return the value to its left when that can be converted to true, and will return the value of the right otherwise. This has the expected effect when the values are Boolean and does something analogous for value of other types. Alright, so we can use this functionality as a way to fall back on a default value. If you have a value, it might be empty, you can put or after it with a replacement value. The initial value can be converted to false, you'll get the replacement instead. The rules for converting strings and numbers to Boolean values state that 0, not a number, an empty string count as false, while the values count as true. So 0 or -1 produces -1 and empty string, or what is this type of ternary operator yields it will just yield this, because this is definitely just going to be false. The AND operator works similarly, but the other way around. When the value to its left is something that converts to false, it will return that value. Otherwise, it returns the value on the right. Another important property of these two operators is that the part to their right is evaluated only when necessary. In the case of true x, no matter what x is, even if the piece of program that does something terrible, the result will be true. And x is never evaluated. The same goes for false and logical and x, which is false and will ignore x. This is called short circuit evaluation. And this was lesson 1. The summary is that we looked at 4 types of JavaScript values in this chapter: numbers, strings, booleans, and unidentified values, which I don't know if that's what I wrote. Yeah, true. See, I kind of remember. So we have numbers, strings, boolean, and empty values or undefined values, right? And such values are created by typing the name, true or null or value 13 or ABC is a string. You can combine and transform values with operators. We saw binary operator for arithmetic. Oh yeah. This is something I need to. This is remainder, right? Minus, less than, greater than. So maybe I can say here uh, remainder, bruh, reminder. Here, spelling. Remainder is percent, and I remember this. I think it's very important to know that, because when you want to the logic when you're writing, when you want strings, for example, like this one, it has the remainder property. It's very important to know. I think it's very, very important to know. Yeah. And when we're done, we might want to come here, and these are a bunch of lessons, exercises in loops that I wanted us to come and do, like a bunch of loop exercises, which we just come back and try to solve them. So let's just finish doing the week so far. So such values are created by typing the name, true, now, string, concatenation. So comparison, there's the equal to, not equal to, equal to, not equal to, less than, greater than, less than or equal to, or greater than or equal to, and the logic and or as well. Several unary operators to negate a number, to negate logically, and the type of to find the values type, and a ternary operator, question mark, colon, to pick one of two values based on a third value. So this gives you enough information to use JavaScript as a pocket calculator, but not much more. Right. This was really cool. So I feel like you really need to just like understand this, because this is the things that are going to be used to even build the next thing. And then after that, after I understood that topic and I thought it was really cool, went to do program structure, and I think that was the second one, right? Cool. I don't even believe I've made such a summary in so lesson 2. So let's go to H2. Lesson 2 is, I think, program structure. Then this is where we're gonna get into things like loops and stuff. Right. So the book was really cool. I did a very good job just making doing like a really, really amazing introduction. So it's like, now once you've understood these things that we use in JavaScript, let's jump into actually showing you how to start structuring a program, which is another very important basic information to have. So the first thing, it was like expressions and statements, and it tried to really explain what an expression is, and what a statement is, and what a binding is. So I think those are 3 very key ideas that I might want to get into. So there's expressions, statements, and binding. So basic information that is going to form the basis of our language. How can I say what an expression is? So I thought an expression was anything, I guess. Yeah. So a fragment of code that produces a value is called an expression, right? So this is a fragment of code that produces a value is called an expression. And let's just write that this is a fragment of code that produces a value, right? So it could be like e.g. 1 plus 1, you understand? Like that's a fragment of code, it produces 2. Okay, so that's a fragment of code. So there could be micro expressions. Then statements is a collection of expressions, and is a collection of expressions, and also like statements form a program. So let's just see that. All right. So this shows up the beauty of a language-based interface. All right. So if an expression corresponds to a sentence fragment in JavaScript, statement, right? A statement refers to a full sentence. All right. So this is like a word, and then this is a sentence. But a program is a list of statements, many statements. The simple kind of statement is an expression with a semicolon after it. This is a program. So this one, close it, is a statement. All right, and it will yield so 1 and false. This will give this a statement. It is a useless program though. An expression can be content just to produce a value. Oh yeah, and I think this is also some very important information in here that maybe I should also capture. All right, so in here we learned the concept of a side effect and return value. Okay, so a side effect would be what happens, something that happens when the code is run, and a return value is the value that is returned when the code is run. And I wonder if there's a better way to explain that, but you need to understand side effects and return values for you to really now start appreciating undefined. So like for example, undefined is a side effect of closing this fast. It does nothing, it's just that's what happens. Okay, let's come and read that. Alright, so it is a useless program. An expression can be content just to produce a value, which can then be included by the enclosing code. A statement stands on its own, so it amounts to something only if it affects the world. It could display something on the screen that counts as changing the world. Let me come into this code and run my console.log, and I'm going to run my, and then it will give me fast. So this is my so so this is my return value. Okay. These changes are called side if let's go back. It could change. All right, it could display something on the screen that counts as changing the world, or it could change the internal state of the machine in a way that will affect the statements that come after it. These changes are called side effects. The statement in the previous example just produces a value 1 and true, which then immediately throws it away. This leaves no impression on the world at all. When you run this program, nothing observable happens. In some cases, JavaScript allows you to omit the semicolon at the end, but here we were recommended that we don't throw it away. And I think the author will talk about the return value in a different state. Now, this was and I think even right now, I think it's a very important lesson to grasp. In understanding the syntax, right? So How does a program keep an internal state, and how does it remember things? We have seen how to produce new values from old values, but this does not change the old values, and the new value has to be immediately used or it will dissipate again. To catch all values and hold, this is the important one, to catch and hold. JavaScript uses a thing called a binding or a variable. So a binding or a variable is a thing that catches and holds values. Let me just write that. Yeah, this is a thing that catches and holds values, right? So think of it as a tentacle from an octopus. You know, when I first watched a programming JavaScript tutorial a couple of months back, and I was trying to get into this, I watched on YouTube Programming with Mosh. And Programming with Mosh said that a variable is like a bucket. You think about it like a bucket. In this bucket, you put your things inside that bucket, so it holds it. And that analogy didn't make a lot of sense to me at the time. But now, this binding idea makes a lot of sense to me. Well, especially why? Because of two things. Because one, now I understand that for bits to be captured in a computer, so bits stored in memory that can be called, that bits need to be stored in memory and called. And when it's stored in memory, it becomes a value, or else it's there. It's just a bunch of bits in your machine. Capacity, memory. I think it comes sometimes with the manufacturer. But because you have so much potential, if you want to create something and call it, you want to put it somewhere. So that it means that also makes sense to use the idea of a bucket. But a tentacle was very important because now you can see that I'm just growing my tentacle to hold this, and then I can grow another tentacle to hold something else, and then I can release my tentacles. And I think it's very easy to think about it, that there's something that keeps growing and comes out of you, other than this like real physical thing that doesn't have a property that can, unless it's like a magic bucket that can flow outwards, right? So expressions, statements, and bindings. And this was so cool. So we learned about let. We learned that JavaScript also has var and const, but in ES6 you're mostly going to use let, and in later chapters they'll tell us why. Var was tough to use, wasn't so cool to use, or it decided giving people a lot of problems when they're using var and const, and they just told us, for now, until we get to other chapters, just be the let guy. And so here you should imagine bindings as tentacles rather than boxes. They don't contain values, they grasp them, okay? They grasp these values that are on your machine. And then two bindings can refer to the same value. So that's why it can't be a box or or a magical bucket. A program can access only the values it still has a reference to. When you need to remember something, you just grow a tentacle and hold on to it, or you attach one of your tentacles to it. So let's look at another example. I thought this was really cool. So to remember the number of dollars that Luigi still owes you, you create a binding, and when he pays you back $35, you give that binding a new value. So what will happen in this code is that you will define this new binding. You're going to create a binding called Luigi and give it a value, right? And then when he pays you, you're just going to take this binding that you've created and subtract this value from it, and ask the console log to give you tell me how much. I will give you 105, and that is the basics of understanding how to hold and to release value. So basically this is let me copy this code, and then let me paste it here, and let me say code, and then Control V, and then I'm gonna say this is the basics of capturing and releasing values from a binding or values from a tentacle, which is a good now idea to think about it. All right, let's move on. So yeah, he went ahead to tell us about how now we can start using everything that we learned in lesson 1, all these types of number values, string type of values and Boolean values, and now to use the idea of having a binding and now our values. Then so binding names can be any word. So here we learned about binding names, and immediately after learning about binding names, a binding name include a $sign or underscore. By the way, I was just curious, what is a $sign in JavaScript? You know, when I was reading code yesterday, I found myself that I don't know. Stack Overflow. The $represents a jQuery function that's actually shown up for jQuery, and like in most languages, the simple is not reversed. Whoa. Yeah. What is the purpose of the $sign in the variable name, and why not just exclude it? Okay, let's look at the most voted answer. Dollar is in a variable means nothing special to the interpreter, much like an underscore. From what I've seen, many people using jQuery, which is what your example code looks like to me, tend to prefix variables that contain jQuery object with our $sign so that they're easily identified and not mixed up with the say integers. So the $sign function in jQuery is a library function. That's all right, fine. So I guess it's in jQuery. All right. However, in ECMA, a template literal. Right. This is what was this? I wanted to know what a template literal was. I might have seen this somewhere. Well, I'm going into new territory, but it's okay. This is the reason for this type of video when we're just not reading. We're giving ourselves time to really get into it. So template literals are literals delimited with backticks, allowing embedded expressions called substitutions. And tagged template literals result in strings, which make them useful for string interpolation and multi-line strings, since unescaped new lines are allowed. Tagged template literals call a function, and the tag function with an array of text segments from the literal followed arguments with the values of substitutions useful to that. Template literals are something informally called template strings, but they aren't string literals, can't be used everywhere. A string literal can be used. Also, a tag template literal may not result in a string. It's up to tag function that creates anything. Alright, do I really understand this? Let's look at this code all the way to the bottom. Description. Template literals are enclosed with a backtick character instead of a double or single quotes. Alright, so template literals can contain placeholders. These are indicated by the $sign and curly braces. So, $sign, curly brace expression. The expression in the placeholders and the text between the backticks get passed to a function. The default function just concatenates the parts into a single stream. If there is an expression preceding the template literal tag here, this is called a tagged template. In that case, the tag express on, usually a function, gets called with the template literal, which you can then manipulate before outputting. To escape a backtick in a template literal, just use a backslash before the backtick. Alright? Expression interpolation. Now to embed expressions within. So what is this? And multi-line strings. So this is a multi-line string. This is probably Probably something different, is it? Let's see. Console.log string text. So right, so this is how to write a multi-line string. You could write string text line 1 n, and then this is a template literal, this quote plus quote plus this string text in line 2. It will give you this. Using template literals, you can do the same like this. I say, okay, console.log string text line 1 string text line 2, and it will give you string text line 1 and string text line 2. Expression interpolation. Now with the template literals, you're able to use the syntactic sugar, make substitutions like this more readable. Alright, so let A be 5, B be 10. Console.log is console.log 15 is template literal of A plus B and not template literal of 2 times A plus B. Then you close that string, and then you close that bracket, then you close out. 15 is 15, and it will tell you not 20. So I think now what I'm learning is it could have been, you could have used this and not. All right, cool, and not this \n. But now to make it better, we're going to use this template literal. Now I understand, and then we can create 2 lines, which is again in JavaScript. What now I'm learning is that the more you advance in JavaScript, the more you make the code less verbose. Does that make sense? Like JavaScript, beginner JavaScript should be like very long code that uses very many words, but the more you advance, you start learning things like template literal, and eliminate some of these basic things that you had in 4 lines into that one. And then finally, when you're like a JavaScript pro, you're writing like very short code like this. So I'm really excited in this journey. Hopefully one day I'll be like a JavaScript pro who's writing these things. All right, so now here, so this was multi-line strings using the \n. Expression interpolation. In order to embed expressions within normal strings, you would use the following syntax. All right, I think it's just what I've read right now. So let A be 5, let B be 10. But in the console log, give me the string 15 is A plus B and plus concatenate and \n not open string plus. No, I think this is the entirely thing. This plus and not. This is the entire thing, and then this string. So if 15 is 15 and bracket not 20. With template literals, you can be able to make use of the syntactic sugar, make it such like this more readable. Let A be 5 and B be 10. Console.log 10. So 15 is template literal A plus B and not 2, and then and not this. So this will go into and not. Cool. It will be so nesting templates. Let's see how else it can be used. All right, this is in ES5. All right, some hard stuff is gonna kick my butt. In certain cases, nesting template is easiest and perhaps more readable way to have configurable strings within a backtick template. It is simple to allow inner backticks by using them inside a placeholder of this template literal, which is a $sign with curly braces within the template. For instance, if condition is true, then return this template literal. ES5, let classes be header, classes plus or equals to is large screen function. Are we calling a function here? And then question mark. How can I read this? Is this the thing? Is this the whoa. Is this the what did we call this? What type of ternary operator? Is it the ternary operator? Icon expander, item collapse. So const classes header template literal is large screen function. Question mark. Template literal string, empty string. Item collapsed. Question mark, icon expander, colon, icon expander. right. In ES 2015 with nested template literals, this is how it would look like. Const classes header template literal is large screen, open a function, ternary operator, icon, syntax is killing me. Template literal, item collapsed, question mark, expander, colon, collapser. So I think what now we've seen is this is the long way to write it. This is the ES 2015, ES 6 2015. This is how you can use template literal to to break that to be down. Man, this is, do I really want to go down this road today? Not today, sir. Not today, but it's be cool to know. Whoa, just look at that. Close it. Did I see it before I started asking myself? Or I saw this and I remembered I saw the template literal in some other function and I was just saying, what am I looking at? So our binding name may include the $ or underscore, but no other punctuation or special characters. Alright, so I think here we mean that when I'm creating binding names, so like let my my learning curve, it could include an underscore or a $, but not any other thing. Okay, cool. That's something even like I didn't know the first time I was reading. So these are some words with a special meaning. So and then immediately after that, we went into thinking about the JavaScript environment. And I'm so lucky because I listened to a YouTuber talk about the weird side of JavaScript, and it really gave me a way to start thinking about this in a more holistic way. All right. I thought I had guests. All right. So the next thing in here, maybe I should make this like turn into H3. Yeah, so that statements, and then so like when I started doing like CSS and HTML, is when I started actually really just knowing that everything that I'm doing right now here on my browser, on my Notion, is code, and someone else wrote that code. H2, the environment, environment. So another basics of understanding JavaScript is, now that you kind of understand, or is it coming to rain? I need to go get some clothes from outside and we'll continue. So let me just pause. Alright, what's up? We're back, man. Just took me 2 minutes to indeed is raining. So the JavaScript environment. I don't know, I'm trying to find some images I saw on a YouTube video called JavaScript the Weird Parts. They're weird. I think this is visit this page. Alright, and I think for me to really and I might even just come and also read this because I watched a video of it on YouTube, and the first line of this thing was that when you opened JavaScript, when you open a JavaScript environment, and a JavaScript environment could be a browser, a JavaScript environment could be node.js. Let's just get that out of the way. So this is a JavaScript environment. And when you open a JavaScript environment, it is not empty. There's something that exists here called window. All right, and just look. This is window, self window, alert, and this already exists. So on your JavaScript environment, this already exists, and I've never done this. So this is pretty cool. So that it can give you a way for your mouse also to like interact with this window. So JavaScript is not always empty. Every time a new instance of JavaScript is run when you open a new browser. It's very important to understand this, because now when you understand this is how we're going later on in our program to understand the control flow. And when they say that when you run this and then this happens and then this happens and then this happens, you'd understand why that happens. So, and I'm just making a mental note that I should probably come and read this. Maybe in the next one, who knows? Maybe in the next video, this is what we're going to do. Or maybe we could just dive in and do it today because we got the energy, and like, why should we, why should we take it to another part? So what I'm going to do, because I got Notion, I'm going to save this page on my Notion, and then I want to save it to inbox. So I'm going to save this to my inbox. All right, here I want to save it to this page, and I say save page. That's going to save it, and that's pretty cool. So if it saves it, I'm going to copy all the entire of these notes, just because, man, just give me dark mode, bruh. Right, so I want to take the entire of this page, and I'm gonna copy like this entire thing, right? Control A. Isn't Notion like an amazing app? And I'm gonna jump out of Eloquent JavaScript in my notes page, and then I'm gonna come back into my Learn.js. Then I'm gonna have this as one like of those notes. So it's called execution contexts and lexical environments, the weird parts notes. All right. Execution contexts, and we just say that for now, and then I'll definitely change. So what I'm going to do is I'm going to open as a page, and I'm gonna have this note here. No, not that, bro. Give me this. Give me this. Give me that, bro. Give me that. Yeah, give me that, bro. So it has synced across my device. From one, this is going just to be in my inbox. I have a bunch of here in my inbox is why I say, oh, it should have been in my inbox. It should have been in my in tray. Ah, that's a whole different place. Okay, it's cool. So saying in my in tray, this is where I most of the articles that I read, I just dump them here. So it's going to exist here. I had wanted to filter this as a whole different topic. Let's just jump out of that very quickly. All right, so it's called execution contexts and lexical environments. Contexts and it's not raining anymore. Lexical environment. The weird parts. Notes from. So the source is hey, let me copy you. So this is my source, my URL. Control V. It's just going to, but this is really isn't. So I usually don't like to do a lot of work like this, by the way. Alright, so tags is, how can I say it? It's just an introduction, I guess. Type, these are notes, then source, JS beginners, web page. Cool. So these are the notes from here. And then of course I can always add the icon, which is the button. I forget where it was. Let's just come here. I feel like I'm taking a lot of time. I need to be reading, and I just can't shake that feeling out of my head. You need to be reading, not this nonsense. Alright, so today I began going through Anthony Alicia's JavaScript and assign the weird parts course. Again, this is an amazing course. So once you know the basics of JavaScript, you have learned how to write your own small programs. Like there's one in the JavaScript program list. It's highly recommend course to learn better JavaScript. Tony's content is slow, methodically, and most important, very helpful when trying to actually learn how JavaScript works under the hood. We're gonna come back to the environment. Just hold on. Let's read these notes pretty quickly. The following are my notes: conceptual aside, syntax parsers, execution, context, and lexical environments. Syntax parser: a program that reads your code and determines what it does if the grammar is valid. So this is a syntax parser is built into JavaScript. Your code isn't magic. Someone else wrote a program to translate it for the computer. A lexical environment. A lexical environment exists in programming languages in which where you write something is important. So a lexical environment. So where the code is written and what surrounds it. And then execution context. That's a wrapper to help manage the code that is running. There's lots of lexical environments. Which one is currently running is managed by an execution context. So these are three ideas that allow code to run. So an example, if I just rushed very quickly, and I'm gonna use this. Yeah. So like this thing inside the if is preferably we can imagine that this code only runs inside this execution context. You understand? And if you were to call it outside here, it probably won't happen. Now that's an execution context. Name value pairs and objects. Name value pair, a name which maps to a unique value. The name may be defined more than once. These are really like short notes, bro. Example of a name value pair: address is 100 Main Street. This is a name value pair. This is a name and this is a value. Therefore, they make the pair the name value pair. Object is a collection of name value pairs. So address, so name value, name dash, value, name value. So this is an object. All right. So global environment and global object. So the global, the base execution context accessible to any and everything in your code. When JavaScript runs, the base execution context is the global object and a variable called this. In the browser, in the global object, this and window are the same. And I think we're going to look at this. Where was I looking at this yesterday? Must have been somewhere. Maybe in chapter 4. In JavaScript, when you create variables and functions that are not lexically inside a function, those variables and functions get attached to the global object. So var A be hello world, then function B, close out, A will be hello world, B will be the function B. Then just window A is hello world and window B is the function B. JavaScript execution context, so the creation phase and hoisting. So most programming languages execute their code one line at a time, top to bottom. Assume there are no conditional statements. Okay? But in JavaScript function, a function or variable can be called even if it comes before it is declared. The execution context has two phases. The creation phase, which has the global object, this, and the outer environment. It also sets up memory space for variables and functions, that's hoisting, which is why variables and functions can be called before they're declared, as long as they're declared in the same execution context. Variables are set up in this phase, but they are assigned the value of undefined. Remember this? Undefined. Which is not equal to not defined in JavaScript. Example, console.log A. A is not defined. Cool. If you try to use the variable that doesn't exist, you'll get uncaught reference error, which it's not defined. But when you say console.log B, it will be undefined. If you use the variable that does exist but declared after its use, the variable will be value undefined. So that's how undefined is done, and I learned that undefined is actually a value and a keyword in JavaScript. So never set your variables to the value of undefined. Alright, so var A is undefined. Don't do this. Don't set it to undefined. Var B is null. Do this to represent the absence of a value instead of setting it to undefined. So let JavaScript just use it to mean undefined and null. Use null instead of an absence of value. So undefined is there's no value. And if you set undefined, you won't know it's because you set set. So Java execution context in the code execution phase, everything is set up in the JavaScript. Global object, this, outer environment, and memory space for variables and functions. And now your code, what you've written, is evaluated and run by the parser. Remember the parser? Conceptual aside, single-threaded, synchronous execution. Single-threaded simply means one command at a time. Synchronous execution means one at a time. So JavaScript being a single-threaded with synchronous execution means that only one command happens at a time, at one time. This is very basic, but I think what I've also learned is you want to think in that very simple steps, but you also want to appreciate that a computer does this in like a fraction of a microsecond. So it would probably do this in like fractions of microseconds and run very, very many big math. But this is exactly what it was doing. If it was doing as slow as I think, this is exactly how it would have been doing. So yeah, so JavaScript being a single thread with synchronous execution means that only one command happens at a time at one time. So JavaScript function, invocation, and the execution stack. So invocation, that's running a function. In JavaScript, we do this by using the parenthesis. This is running a function. When functions are invoked, a new execution context is created and placed on top of the global execution context. This is the execution stack. Whichever function is on top is the one that will be currently run. This is the one that is on top, the one that is going to be currently run. I guess not the one at the bottom. So like function B, function A, and then inside pass the parameter of B, call B inside this A, and then A, I think this is one that will be run, and then this, and then this. Okay. Even for me now it makes sense, because I was wondering why is it not this one. When JavaScript execution stack, when the top function completes, it is popped off the stack. It does not matter which function is on top lexically. The execution stack is based on the synchronous function calls. It pops it, goes to the next one. When the new functions are invoked, its own execution context is created as well. This variable set, function hoisting, etc. JavaScript functions, context, and variable environments. A variable environment. This is where the variables live when created and how they relate to each other in memory. Alright, in the picture above, each execution context has its own variables, and those variables are in the local scope. Each myvar is unique in the above case. So this is the variable environment. So this myvar is unique to this function B. This var, my var2, is unique to function A, and then this is just unique to calling A. And this is very important for somebody to understand. My body taking a beating. All right, let's push a little bit further so that we can really just milk this experience. Each myvar is unique in the above case. Okay, JavaScript scope chain. Every execution context has a reference to its own outer lexical environment. So function A, function B, and this. JavaScript scope chain. If JavaScript can't find a variable value in its execution context, then it goes down the scope chain. It goes down the scope chain. Goes down the scope chain. Alright, which is based on where the function is written within the JavaScript file. So it will start here. If it misses here, it will go down the scope chain. So for example, function A, then you call function A, and inside function A you pass in the parameters of function B, and then inside that you pass the function of console log myvar. And then down here you describe that let myvar be 2, then call B. So I think what will happen, it will first of all it will look here and won't find my var, so it will get my var, and then finally it will run function A. JavaScript, and I'm already tired. Oh, but does he continue? How does it just end like that? Or did I not copy the whole thing? Oh, so yeah, I think this is as much as our author wrote. This video it leaves this idea of lexical execution. It also goes into talking about things to do with synchronous, asynchronous, and that was cool. Just beginners, get over 100 great ideas for beginner JavaScript projects. Here, don't ask me to give you my email. It's a rock, paper, scissors, JavaScript Hangman app, JavaScript to do app, project, finish just beginner, I would say project, start Andrews Node course, finish mid modern JavaScript course. JavaScript is so much fun than CSS. It's interesting. I don't know why. Maybe it's because it's hard. For me, maybe. Oh, he's selling something here. His site is pretty boring. But I get it. Programmers don't care about something like that. So there's counter, pass the message, counter, background image slider, testimonial, filter, model, calculator, tip, form, to-do list, grocery cart. Haha, nice. I'd like to do this for my wife. Grocery list 2, course form project, flashcard project, budget application project. It would be nice. Coffee shop project, no picture, random joke. Alright, yeah, I've seen such sites. Or like a meme generator, like a random meme generator. Random person Ajax project, HTTP. Some of them he hasn't really like defined. But we have to give it up for this type of or quote of the day, or verse of the day, or SMS of the day, BMI calculator, weight conversion, background color switcher, 2D breakout game. Yeah, I'd love to create this logic. Yeah, so that was cool. Should I? Is this important to me? Should I bookmark it? Do I want to come and do this at some point in my life? Not sure. Maybe, I mean, yeah, I could see the value of this type of so let me just save it on my Notion, and I'm going to save it on my in-tray this time. Bro, all I'm asking is, I wish he made a table, or like a Google Sheets, or a she. How long? If you're a true beginner, I recommend it with the modern JavaScript course on his website. Andrew's course alone. You'll need about an hour to several hours per each JavaScript project above. Some a simple JavaScript project for beginner will take about 10 minutes, and others can take up to an entire weekend. But no fear. Which one should you start with? I think there's just a lot of information. You could have represented it so much better. But it's okay. It's also just very valuable at the same time. Alright. So the next 50 plus come from Actually, you could do 100 days of code with this, which could be so much fun. I mean, personally for myself, I'm looking forward to like to do every day, like to spare time every day to do this. That's why I've started with just reading along like these JavaScript books, and I really want to just like grow into taking time and doing courses and doing this type of stuff and just figuring out this language. And I want to put in the next maybe 3-4 months in this. Not maybe, I'm gonna put the next 3-4 months in. Why did I do that? I'm just curious what happens when you click this. I'm gonna close this page, don't worry. My brother says I open way too many tabs. Right? Oh, it's on Udemy. It has 4.8 stars. I like just just about the same things I'm doing by reading Eloquent Javascript, I guess. Oh yeah, it's the same thing. I always like to come on Udemy and watch a trailer. Always like the trailers, like the effort these people put in the trailer is really cool. Just block. I don't want.
Hello and welcome to the Modern JavaScript Bootcamp, where you're going to learn the JavaScript programming language from the ground up. I'm Andrew Mead, a longtime Udemy instructor with over 150,000 students, and I'm back again with a brand new course designed to teach you the fundamentals of modern JavaScript. Now, I designed this course with two types of students in mind. The first are those who have never used JavaScript before and are trying to learn the language for the very first time from scratch. The second are those who are already using JavaScript in their day-to-day development, but want to gain a better sense of mastery over the language and explore those awesome new language features. There's a lot packed into the class, so let's take a look at what's inside. This course is entirely project-based. That means you'll be using everything you learn about JavaScript to build some awesome web applications. During the course, you'll end up building 3 apps. The first is a note-taking application. This multi-page app comes with support for creating, editing, and deleting notes, as well as support for data storage and note searching. The second app is a task manager application designed to test your skills by requiring you to write most of the application code. You'll build this app using what you've learned in the class. The third and final app is a Hangman word game. Here, you'll learn about asynchronous programming and fetching data from third-party APIs to use in your app. This course is designed around writing code, not watching videos. I've included over 90 programming challenges designed to test your skills and reinforce what you've learned. This will give you practical problem-solving experience, so when you're done the class, you can go off and write your own apps. You don't need any knowledge of JavaScript, HTML, or CSS to take this class, and the class comes with a PDF reference guide. If you forget how something works, there's no need to dig through hours of video. The reference guide contains notes for each lecture, as well as documentation links and code samples. Learning something new is a huge investment. You spend hours working through a course only to get stuck up on something small. You ask a question in the course Q&A and you don't get a response. Now, that's not how things work here. I work on my Udemy classes full time, and I'm in the course Q&A every single day, and I answer every single question that comes my way. So if you're moving through the class and you get stuck installing a program, or you run some code and it's not working as expected, all you have to do is ask a question and you'll get help right away. I offer fast and friendly support to all students. It's one of the reasons.
Yeah, it's cool. Thank you for your work. Let's take to Eloquent JavaScript for now. I'm really committed to like Eloquent JavaScript, man. I told myself I'm gonna commit to this, and I don't wanna not commit. So now that we've read this, it took us out. Let's go back to Learn.js and jump into Eloquent JavaScript. And when the page is open, we can continue with the environment. I really wanted to I'm feeling like my time is running and I want to bounce. I really wanted to be able to, I mean, I can at least finish this, right? I can at least finish this because I had such a hard time going through this. I can really understanding. I had to watch a couple of videos because even after I was like, bro, what, so environment. So the collection of bindings and their values that exist in a given timer is called the environment. And when a program starts up, the environment is not empty. It always contains bindings that are part of the language standard. And most of the time, it also has bindings that provide ways to interact with the surroundings. See, for example, in a browser, there are functions to interact with the currently loaded website and to read the mouse and the keyboard input. Functions. A lot of the values provided in the default environment have type function. A function is a piece of, so that's important information. A function is a piece of program wrapped in a value. Alright? Such values can be applied in order to run a wrapped program. Alright, so what's a function? So let's just, so the environment, how can you say it? How can we say it? Let's do that again. Bindings these are bindings that are part of the language standard that runs every time you open a browser or any other JavaScript environment. And then functions. So a function is a piece of program wrapped in a value, a piece of word wrapped in a value. What is the word? A piece of program wrapped in a value, and we'll discuss that. A piece of program a value. So for example, like, what does this mean? So so to really understand this statement, let's remind ourselves what is a value and what is a program. So a value is we say there are bits that are held and released in a JavaScript environment. So for example, strings, numbers, booleans, and identifiable values. So this is a value. And what is a program? We said that this is a list of statements. Okay? But we know that statements is a bunch of expressions. So now that we know that, now what is a function? A piece of program wrapped in a value. So if a value is 1 and we wrap a piece of program inside it, this program, so let's say value 1, value value 1, this program. Holistically thinking, this is what a function is. A program that is wrapped in a but since this is let me turn this into something like a call out or something, you know. I wish this could come here and this could come here and this could come here. All right, so these are my thoughts. So now let's go back to understanding how a function is written. So the author used this function called prompt to make us understand. So in a browser environment, the binding prompt holds a function that shows a little dialog box asking for user input. So for example, prompt, it will hold a program that asks for user input. And I guess this program is a little bit tough to write. Maybe it's very long, probably, but this is what basically this is. But the best thing is it has kind of abstracted all this thing that it has to do in a way. All right, so when you just call prompt, and this is how you call it, enter passcode, it will ask you to enter passcode. So yeah, and that's the thing, calling. So executing a function is called invoking, calling, or applying it. And it's pretty basic. Okay, let me just copy paste because now I don't want to write like all those words. Control V. It's called invoking, calling, and applying it. And it is done by using two brackets. Say prompt like that. I remember that. I remove this here. So usually you'll directly use the name of the binding that holds the function. The values between the parentheses are given the program inside the function. In the example, prompt function uses the string that we give it as text to show in the dialog box. Values given to functions are called arguments. Alright, so maybe we can rephrase our thing. So this program, they're called arguments. So let's change this. Therefore, it is value 1 arguments. Right? That was pretty cool. Okay. So different functions might need different number of different types of arguments. The prompt function not used much in web programming, mostly because you have no control over the way the resulting dialog looks like, but it can be helpful in toy programs and experiments. And then we also have a console.log function. So now we are being told about return values. Remember how we talked about a side effect and a return value. So a side effect would be something that what happens when you run like this. Some programs would give a side effect, another one would give a return value. So showing a dialog box or writing text to screen is called a side effect. A lot of functions are useful because of the side effects they produce. Function may also produce values in which they don't need to have a side effect to be useful. For example, the function math.marks takes any amount of number of arguments and gives back the greatest. So when you run console.log math.max, when you have 2 and 4, it will give you 4. When a function produces a value, it is said to return that value. Anything that produces a value is an expression in JavaScript, which means function calls can be used within large expressions. So here a call to math.min, which is the opposite of math.max, is used as a part of a plus expression. So console.log math.min 204 plus 100, it will say, okay, fine, the minimum of 2 and 4 is 2, plus 100 is 102. The next chapter explains how to write your own function. That's very, very cool when we review what we learned there. We just solidify, and it's like we're going really, really slowly, but it's okay. So control flow. When your program contains more than one statement, the statements are executed as if they are a story from top to bottom. All right. So now after we've learned functions, this is the introduction to functions, and we're really going to get deeper into functions in lesson, I think in lesson 3. But what now I'm getting the sense of even how this book is designed is they teach you the basics, and they're going to build on this information as you keep going, and it's just pretty important for you to learn. Now, we're going to look at another important thing where actually I had a really hard time man control. I remember having a very hard time really getting the grasp of now how this is going to work, and I think even that's when I went to do a bunch of these loop tests, and I wasn't very successful in some of them. I found myself really just thinking so hard, like, so what is this again? So what is this again? So what, wow, okay, fine, I need to define a variable first, but which variable do I decide? How do I know the variable that would work? There's just so many questions that kept coming up. But when your program contains more than one statement, the statements are executed as if they are a story from top to bottom. And this is basically what now we read in the other guy's thing, that code is executed from top to bottom. And how did he talk about it? No. It's probably another. He talked about it. What was the word? One after the another, then top to bottom. I just read it. I'm gonna look it up. So this is where I'm going to pick up my review, and I'm going to review all this like loops things, and then when I get back, and then we're going to work through just really getting the loop, and then we're going to do fizz bars, and then we're going to do this exercise of the chessboard, and then we're going to take our time and really see if we can work through some of this loop lessons, so that we can just really start getting into loop, so that when we move into functions to review what we've read so far in our notes, it becomes very easier. So now when I say I'm gonna go to when I say I'm gonna come here, all right, and move now to higher order functions, I want to be able to have understood all these areas, and I just want to take the time, the necessary effort to try and do all these exercises. I've found it's very easy just to read these things, even watching videos. It's easy to watch videos, but you want to really just get into the meat so that you can understand how it happens. I believe in the next week I mean, the next month or so it'll be done, and we just see how fast we can understand JavaScript. So that's done for me right now. I'm gonna take a break and do a bunch of other few things, and we'll be back. We are done. Peace. Alright, let's just wait for 2 hours. 5, 4, ah,